Okay, what we're going to do in this lesson is just kind of look at some things that we've learned about lines a long time ago. We're just going to have a refresher on them, and they're important because they have a big influence on how we can look at and understand and analyze circles. So we're just going to come back in time and reflect over the midpoint and distance formula for a few minutes and practice some of these problems out and just see kind of where we are on these guys. And so just remember, if you're looking at the midpoint formula, then if I give you these 2 points, this guy right here, he's the midpoint. Okay? And we're really interested in this point for a lot of reasons, and you're going to discover why as you start working through some of this stuff. But we want to know where that midpoint is. And in order to do that, we just apply the midpoint formula. It's very simple. You may or may not remember, but we're going to label this guy up here x1 and x2. We're going to label the bottom guy down here as y1 or x2, y2. And let me redo this top guy. He should be a y2 here. And in order to find the midpoint between the point -3, 4 and the point 2, 7, and we can do this without graphing it and measuring and dividing that distance by 2 and calculating exactly where, we just use our midpoint formula. So we're going to take x2, which is purple, so x2 is 2, minus, and then we're going to take x1, which is -3. So don't forget the parentheses here, and all of that's going to be over 2, and that's going to give me my x coordinate. Then my y coordinate is going to be y2, and again, I've messed this guy up. This should be y1. We're going to take y2, which is 7, minus, and then y1, which is 4. And again, all of that's going to be over 2. So this is how the midpoint formula shapes out. And you just do your math. 2 plus 3 is 5. So I've got 5 halves for x. And 7 minus 4 is 3. So I've got 3 halves for y. This is the midpoint formula. And this point right here, 5 halves and 3 halves, is exactly halfway between x1, y1 and x2, y2. Well, what about the distance formula? What if I want to find out how far it is? What if I wanted to know the actual length of this green line right here, this guy right here? What if I wanted to know the length of this line? Well, if I know the 2 endpoints on that line, if I've got the 2 endpoints on this line and I know what they are, then I can use the distance formula. And again, we're going to just label our points. I'll label them better this time, but we're going to have x1, y1, and we're going to have x2, y2. Okay, and we just substitute these things right into our equation for the distance formula every time. And one way that you can think of this is stop minus start. We're stopping, we stop at x2, y2, and we start at x1, y1. So if you think about it this way, if you do stop minus start, okay, then this will get you your setup for your distance formula. So let's just plug these guys in and see what we've got. We're going to have the square root of d equals d for distance, the square root of, and then we're going to have x2 minus x1. Well, x2 is -6 minus, and then x1 is 5. And he's going to be squared. Plus, and then y2 minus y1. So y2 is 4. Minus, and then -7. Make sure you put that -7 in parentheses. And we'll square him. So all of this is under the radical, and we can just work it out from here. So we're going to have the square root of -6 minus 5. That's going to be -11 squared. Plus 4 plus 7, that's +11 squared. And anytime you square a negative number, it becomes positive. So this is going to be 121 plus 121, and the square root of 242. Okay, that's your distance. Well, a lot of times we don't necessarily work with distance as a square root type of a number because it's hard for us to tell. So some of the things that we've learned or have studied is that we can reduce this radical. One way to reduce the radical is to go ahead and make a factor tree. What numbers go into evenly into 242? And the first one that I see right off the bat is 2. That's going to give me 121. And then that's going to be 11 and 11. So this is actually going to be 11 square roots of 2. A lot of times that's a perfectly acceptable answer. Every now and then you work it out to a decimal point. And when I look at a decimal of that guy, let me punch it in. Square root of 2. Times 11 is 15.556. And we would say that that's approximately what 11 times the square root of 2 is. Usually what we're going to want to do is stick to this guy right here. So there's your distance formula and your midpoint formula as a little practice for what's coming up.